Good morning and welcome to Poem Physics 365. Physics every single day of the year. Physics past, present, and future. The podcast doors are closing.
Alright, friends, hello and welcome to Poem Physics 365. You are in the physics zone where it's all physics every hour of every day of every year. I am your host, Eli Hibbett, and let's waste no time on Thursday, the 28th of January, 2016. On this day in physics, 28th of January, 1613, the planet of Neptune may have been discovered, unbeknownst to its observer, Galileo Galilei. According to his observation records of that night, he noticed what he believed to be a star very close to the planet Jupiter. This star does not match any current records. For 3 nights it was observed, and then had moved to an unobservable part of the sky. Neptune remained under the radar for another 233 years until it was formally discovered as a planet by Urban Le Vernier, who predicted its existence using only mathematics, and by Johann Galle, an observational astronomer who actually first found it, visually, in 1846. Neptune's year is 164.8 Earth years long, meaning that since we first discovered it, it has only gone around the sun once, in 2011, plus a very, very little bit more. So that's what's going on on this day in physics and history. Let's take a look at the word of the day. Inertia. Inertia is the word of the day, and inertia can be embodied by the following phrase: a body at rest remains at rest. Inertia is an object's opposition to motion or its desire to remain inert. It is also responsible for a body in motion tends to remain in motion unless acted on by an outside force, courtesy of Isaac Newton. So, if we have an object at rest or not moving, we will not see this object move unless something happens to it which would induce motion, such as wind or a push or another sort of action like that. And if this motion were to occur in a deep space vacuum, let's forget about air resistance, essentially, it would continue moving along with a constant velocity unless there were something to stop it. These properties are referred to as inertia. When you get in your car and finally turn onto the highway, getting on the on-ramp and starting at presumably 0 mph, your car's engine must burn a considerable amount of gasoline to get the car up to 65 mph. And what the engine is doing is overcoming the inertia of the car or its desire to remain at 0 mph. Once on the highway, we still need to have our foot on the gas, but we're burning considerably less gas, right? In a frictionless and air-resistanceless world, we wouldn't need to have our foot on the gas at all. We'd just be cruising along forever, although braking would become something of an issue. On the highway, the only energy expenditure of gas is to overcome the resistive friction of your tires on the road, because once in motion, the car's inertia wants to keep it going at whatever speed you set. And we're forgetting sort of little things like, your tires against the, how would you say it? The bearings and everything else like that. But friction is the only thing you're fighting against at that point. So that is the word of the day. Let's take a look at our third segment here. The killer resource. YouTube video. Head over to the blog, pwnphysics.blogspot.com. And it's a video. It takes a look at the horizon and shows you what would happen if the moon were replaced by various different planets. And actually does a really good job of visualizing that. So I think that's going to do it today. And we will be back tomorrow for a little more. Take care, guys. I'll see you tomorrow. Bye-bye.
The pod bay doors are reopening. You may now resume normal life functions.